Hello everyone, welcome to Fanshawe College, and also welcome to this course. We normally refer this course as Controls 1 because after this one we will have a series of course built on top of this. Right? This is the very first course. And my name is Michael Zhang. I'll be guiding through this video to help you with the orientation of the lab room and also the Lab 1 activity. Speaking of the Lab 1, also the quiz, I need to show you the course website, right? So you probably will see the course website similar to this one. At the time when I'm making this video, I don't have the access to the course yet, right? So, but it will be very similar to this, right? So at the first page of the course website, you probably see this announcement, right? Very similar to this, and as you can see, I obviously this link it's a fake link, right? Because I need to make this video first, then I will post on the YouTube and then make the link available to you. And probably this is where you start this video to watch this video right now, right? So that's where you start it. So I just want to remind you, all right, in the moment I'm going to show you there's an online quiz associated with this video, right? This quiz is pretty relaxed. I didn't set up any time limit, so that means you can take as long as you want to complete it, and you don't even need to finish it in one shot, right? So if you need to take break in the middle, you can do that. The system will save your answer, then you can come back to continue work on that. But I just need to remind you, all right, you need to complete this quiz as earlier as possible because this quiz is the released condition for other labs. So if you need access on the course website to other materials, you have to complete this quiz first. And also the result of this quiz will be the mark of your Lab 1. Alright, so this is just let you understand what we're gonna do with this video and also after, right? So first, I need to explain a little bit of why this virtual lab, right? So lab normally on the in the fall term, Lab 1, the week 1 will be orientation time, right? So and plus we will have a holiday on the first day of the week. So that means with the bigger class, which we normally have multiple sections, some of the sections will not have the lab during the first week because of the schedule and timetable, right? So that's why I want to make this lab virtual, right? So we can still get some things done by doing this way, right? And also, but what I mean is that if your lab session is scheduled, maybe for example on Wednesday, Thursday, your lab session will not be affected by the timetable. You can also go to the lab room by your timetable, right? So actually that's encouraged. I encourage you to attend the lab if you can, right? But with this virtual lab tour, it's optional, right? You don't have to, but it is encouraged to go to the lab room according to your timetable. Then you can talk to your lab professor in the lab, and then you can also have some you can even watch the video and do some real activity on the equipment, right? If you're ready to go, right? So that's what I want to know at the beginning, right? If you don't have the lab scheduled in the first week, this virtual lab will be in place for you to catch up. Then if you are okay to attend, that's good. Right, so that's beginning. So during this virtual lab, I'm going to talk about 4 sections. So first, there's some shop safety presentation, and I need to talk about it. You will see this is required by the college policy. All right, so I will do that first. Then we'll talk about the DMM. So that's part of your toolkit. So everybody got a bag from the program, right? So for the devices you will use in the courses. So one thing is the digital multimeter. So I will talk about that because we're going to use that in this course in the lab. After that, we will do a brief introduction for electrical switches and circuit wiring. So that basically is the foundation of this course. We will do the intro. Right. So then, of course, I will talk about the lab equipment. Right. So that's something you will work on for this whole semester. Right. So let's do the safety first. Right. So this is a presentation on the safety policies. All right. So I will post this PDF on the course website. You can download. You can look at all the details. All right. But for now, I cannot go through every single sentence with you. It's impossible. I will just point out some of the highlights. All right. So let's go to the some introduction. Again, you can read by yourself. There's something you can see here. I have a highlight here. So you can see this is required by the college. Right. So the first lab period, which right now the first week, right? So we need to provide some of the training and orientations. All right. So this is what I'm doing now. Right. So as you can see here, you need to have the safety we call PPE, right? Personal protective equipment. So some of the requirements there include, you can see here, eye protection and footwear. And I don't think the hard hat, hearing protection, shop coat for will apply for this course. At least I know for this course we only need eye protection. The footwear you need to have, but not for this course. Like automation, the next course, Controls 2. This is Controls 1, right? Controls 2, definitely you will need to have the footwear, like the safety boots, right? So with the safety glasses, that's the requirement, right? You need to have the sight shields, right? So I believe that's part of your toolkit. So within your tool bag, you should have one pair of the safety glasses available, right? And also, I think they are also available at the bookstore, right? So again, the footwear is mandatory in some designated shop area, right? But not for this course, right? So for the Controls 2, if I'm doing the orientation, I will let you know that. All right. But for this Controls 1 course, you don't need safety boots. All right. Then there's some, you can see here, there's some guidelines. All right. So there's something I want to talk about it at the basic. All right. So that's similar requirement will be enforced in some of the workplace. Like maybe in the future, after you find a job on the factory floor doing some electrical work, and that's probably part of your company policy, right? So you can see no jewelry and losing clothes that could increase the possibility of injury should be wear in the shop, right? So that's a pretty common requirement, right? So you can see here, those are the detailed requirements. Again, if you want, you can download from the course website to look at that, right? So also other things very closely relate to the course I need to point out, right? First, with all safety equipment, we don't want to remove or bypass. Some people just at workplace, some people try to be smart, right? So something that that's quote unquote be smart, to try to defeat or bypass some of the safety measurement, which is not wise, right? So we do have some safety safety measurement in the lab. We need to follow that, right? And also, before you work on the equipment, you need to check if there are any previous damage happened on the station, right? For example, when you walk in the lab, right, some of the equipment maybe is damaged from the previous section, right? You got some exposed live wire, right? So you don't want to touch it, right? So you need to be aware of that. Once you observe that, you can see here, you don't need to crack it or operate the equipment. You don't want to do that, right? So instead, you want to let the professor know, right? Whoever is supervise the lab should be responsible for that, right? It's not your responsibility to crack or even make some changes, fix the problem, or maybe even operate the equipment regardless the problem. You don't want to do that, right? And then the other thing is that relate to the behavior and attitude, right? So no horseplay or practical jokes, right? So some of the equipment when it's operating, there's some very serious consequences. If we have something we didn't follow the procedure, then that's not good, right? So we need to be aware of that, right? So keep in mind, all right? So the other thing you can see here, proper cleanup disposal procedures. That's normally at the end of the lab session, or maybe there's something happen. For example, there's some oil, right, spill out, right? So something like that. We need to follow procedures, right? So be aware of that. Also, if we have some heavy equipment or something we need to process, we need to be careful, right? Luckily, in this course, in Control 1, I don't think that will apply this very closely on there, right? And some medical attention must be reported immediately. So, for example, if you have something happen, hopefully not, right? So nothing happen in the lab, but if they do happen, we need to report. We need to that college to know that, to follow some of the policy, all right? And especially some of the, you will see that later. I think it's here, right? So you can see. Oh yeah, you see here, right? So especially with some, if we have some blood-borne diseases, right? So we need to be careful, right? So I skipped some of them. Let me go back here, right? No person should leave a machine or equipment unattended. Unattended. That means you start a machine, and then for example, if you need to go to washroom, you need to stop the machine before you go, right? So that's something. It's just as an example, right? You don't want leave that run by itself, right? So that could pose a dangerous situation to other people. And that's the other thing over here, right? So if the lab professor found you some student under influence of drugs or alcohol, and they will have to be dismissed. You have to leave, right? So because not only you can injure yourself, you also pose some potential problem for other people, right? And also on top of that, it's just of my personal comments. I noticed some of the students also have job, right? So work on even work on night shift. So if you don't have a very good sleep and you didn't take care of yourself, and then in the during the lab, you may also have some sort of problem like that, right? So it doesn't necessarily to be drug or alcohol, and that should be also part of under this policy, right? So we just do this for the safety reason, right? So if you miss lab, we can always catch up, but we don't want get involved with some of the safety problems, right? So later on, you'll be asked to acknowledge for this part of the orientation, right? So that's just the first part, right? With the shop safety presentation. Okay, so I use this to remind me also that you. So if you're watching this video, you can. I suggest you pause this video, because on the FOL quiz, right? So you will have some questions related to this, right? So where's the quiz? I forgot to show you. Let me go back to here to show you again. So you can see this is the course website. Of course, similar, right? This is not exactly the same as your course, but you will see similar setup. On top, you can see here there are some menu options, right? One of them is called evaluations. So if you click this, right, once you click this, you will have other sub menus, right? One of them will be the quizzes, right? So if you click this quiz option, you will see lab 1 is here, right? Again, this is just for you to see where do you get this one, all right? I will set it up for our course website. You will see something very, very similar to this. So that's where you see the online quiz. Then you can click this link to work on that, right? So remember, I talk about, you can see here, when I click the course name, you will go back to the first page again, right? Remember, I just talk about the quiz, right? So I pretty relax the rules, right? So you can take your own pace to complete the quiz, right? But you need to do that as earlier as possible, right? So this is the first part, safety. Let me close that. All right. So let's move on to the next one. All right. So this is the DMM. All right. This is as part of your toolkit. Right. You should have 1 meter like this. Exactly. I think that's the model you will have. All right. And also, I have the picture here. You can see. Let's briefly go through this. All right. So you can see the number 1. You can see here that's the LCD or LED to show the numbers. Right. The measurement on here. There's a button here as on and off. Right. And the hold button is just like if the number is changing, fluctuation, you want to have a fixed number, you can press this button, right? When you release, I think that should cancel the function. Normally, we don't have to use this a lot, right? So number 4, point to a dial, right? So you can see here there's a handle. Around this, you will see different features, right, about the digital multimeter, right? We call that multimeter. It just because you can see that you can measure different part, right? So in the video you'll see that. So you can rotate to point. You can see here. You can use that will be the pointer to point to different part of your function. Right. At the bottom, you can see here there you on your meter on this particular model you have 4 sockets, right? 4 of them, right? So some people call that socket, some people call the jack, or some people just call plug in, right? So that's where the probe, the cable plug in. So you have 4 of them. One of them is what we call COM. So that's the one we're going to use a lot. And in this course, we're also going to use the other one. this one you can measure voltage, temperature, resistance, continuity, or frequency. All right, so that's something details we'll talk about later. All right, in this course we don't use all the functions. All right, we only use part of that. So just in case if you want to know, you can see the cable plug in. That's exactly the two sockets we need to plug in normally. Right, black going to common, red going to here, and then that's the other end of the probe. Right, so you use that to measure the circuit. All right, so there's a YouTube tutorial. We will watch this together. Right, so that's where I want to open. All right, so let's watch it.
I'm going to cover multimeters and how to use them to measure voltage, current, resistance, and continuity. First up, where do you buy a multimeter? Well, multimeters are everywhere. You can get them at Radio Shack, Sears, dollar stores, Walmart, Amazon, eBay, whatever's easiest for you. Okay, so how do you choose which one to get? First up, at the bare minimum, make sure the meter you're looking at can measure voltage, about accuracy. Plus or minus 2% is usually good enough, and even cheap multimeters these days will be that accurate or better. Next, the multimeter should have a digital as things as possible.
So I will
let's
skip
get this one. $50, it'll have a multimeter. How do you use it?
Right,
let's start with measuring DC voltages. First, check the cables. Make sure the black lead is in the jack labeled COM or common. And once it's in there, you'll never need to take it out, because the black lead always goes to common. The red probe, on the other hand, is something you'll have to pay very close attention to. If you plug it into the wrong jack, you will blow a fuse in your multimeter. We want to measure voltage right now, so I'm plugging in the red lead into the jack labeled volts, not amps. Next, set the dial to measure DC voltage. Touch the red probe to the positive terminal of your device and the black probe to the negative terminal of your device, and you should get a voltage reading. If you get the wires backwards, that's okay. You'll just get a negative reading on your multimeter. And that's actually a good way to figure out polarity. Now you can measure voltages in pretty much any DC circuit, as long as you're careful to not short anything out with the metal probes. Okay, let's move on to measuring AC voltages. Set the dial to the AC voltage setting, and again make sure the red lead is in the jack labeled voltage. Touch the probes to the AC voltage source that you want to measure, and you'll get your reading. As long as you don't touch the metal parts of the probe or short them out, this is perfectly safe. And as you would expect, there's no AC voltage coming out of this DC battery. Measuring resistance is easy too. Make sure the red lead is in the jack labeled ohms for resistance, and set the dial to the resistance setting. Here is me measuring the resistance of the skin on my hand. Here's me measuring the resistance of a resistor. And here I am measuring the resistance of a speaker. Now you might be wondering if you can measure the resistance of something in a circuit. Well, unfortunately it most likely won't work. You're going to have to remove the resistor from the circuit before measuring it. Next, let's talk about continuity. Measuring continuity basically just means checking whether or not there's a good connection between any 2 points in a circuit. To measure continuity, make sure your red probe is in the jack labeled continuity, or in my case resistance, and set the dial to the continuity setting. Test that the continuity function is working correctly by touching the probes together. Whenever there's almost zero resistance between 2 points, the multimeter will beep. You can use the continuity function to check if cables are internally broken or not. In the context of circuit boards, if there's a good copper trace between any 2 points, the multimeter will beep. If the circuit board is messed up, no beeps for you. Finally, let's use our multimeter to measure current. Set the dial to the amp setting. For almost all multimeters, there's going to be a separate jack just for measuring current. My multimeter has two, one for currents up to 10 amps and one for currents up to 400 milliamps. I usually start out with the amps jack, but if I need more accuracy, I can switch to the milliamps jack later. Now, measuring current is a little trickier than the rest of things. I can't just touch the probes and get an amp reading. In order to see how much current is flowing through a wire, I have to cut the wire and splice in the multimeter in series with the flow before I can get a measurement. Here I have a simple circuit with a battery pack, a motor, and some wires. In order to measure the current drawn by the motor, I cut the wire, splice in the multimeter, and now I can see that the motor is drawing 60-ish milliamps. If I want more accuracy, I can switch to the milliamp settings, and now I can see that the motor is drawing somewhere between 57 and 63 milliamps. Alright, Thanks for watching, and have fun with your new mode.
Okay, all right. So I think a couple things I need to talk about from this this tutorial. All right. So your digital multimeter will be used in different courses, right? So, but in this one, Controls 1, mostly we will use to measure resistance and voltage.
Welcome.
Right? You notice on the current is a little bit complicated. All right. So
and start committing them to memory.
The other courses will
Switches
also
are
talk about
devices used
the
for
usage
opening and
of the
closing
DMM
circuits.
in their course. All right, you need to follow their guidance. All right, so the other thing I want to talk about is the remember within the video,
Welcome.
the tutorial, there's
Switches are
a
devices
continuity
used for opening
check
and
on
closing
that. You
circuits.
also have this feature on your meter. Right. So what exactly is the continuity that already explained? All right. So remember that video in the video mentioned it's almost zero, right? Zero resistance, right? So that means it's very similar to measure the resistance, right? So that's what I will talk about. Sometimes continuity feature is good. Let's go back here, right?
A single pole,
you can
single
see,
throw, or SPST switch
on your meter,
has
right?
one
If you
movable arm and
rotate
affects
your
one
dial
contact
point to
point.
here, you see
When
here
the arm makes
that
contact,
represents the
the
beeping
circuit
sound,
closes.
right? So if you point to here, that means you choose this meter for the continuity checking. All right, so that's the feature you might want to use, or you can just use resistance measurement, right? So if you just use regular resistance, you will see the actual reading on the resistance, right? So the reason I want to talk about that is that on here, right? So I have
number of
the
arms,
instruction
and throw
menu
indicates the number of contacts
for your
affected by it.
meter, right? So I will also post this PDF on the FOL,
single
right?
pole
So you
double
can
throw,
read that
or
if you want.
SPDT,
There's
has
one
one
part
pole
I
and two
want
throws.
to
turn
let
a
you know
stairway
about
light
that,
on
right?
or off
So
from
you
the
can
top
see
or
here,
bottom
right?
of the stairs,
During the
one
on-off
option
testing,
is to
so that
install
means
a
you want to
three-way
check
circuit with an
the
SPDT.
switch, right? If it's closed or open, remember you can see here, right? So that's what I just mentioned, right? If the measured circuit resistance is not greater than about 50 ohm, that should be 50 ohms, the buzzer will sound continuously, right? So that's where basically the beeping sound they call audible continuity testing, right? So as you can see here, right? So that's what you need to be aware. So most meter will have this, right? Use 50 as the line, right? Anything if you have the resistance below 50, the beeping sound will
simultaneously. Many times
you will have the buzzer, right?
Open and close two energized lines
remember
the heating
what I mean is that in the
They
lab
use a
room, right? So we
DPST.
work in group, right? You will have a lot of people work in the same there testing, right? You may hear the beeping sound here and there all the place, right? Sometimes maybe you're not sure if it's your meter is beeping, or maybe people the station beside you, right? So from there, so that's could be some problem, right? If you found that confusing, you can also switch to the resistance reading, right? And also less 50 ohm, right? So that means if something it's just a little bit over 50, right? So for example, it's only 55 ohm, right? Not big difference with the 50. And then if you use the continuity testing, you won't be able to hear the beeping sound, right? But if you measure the resistance, you will see that that's very low resistance, all right? So that's something actual I want to talk about it, all right? So
a normally open push
this
button
is here.
or NOP
The other thing.
the between two contacts
current measurement,
when the
right? So
button is
in the
when the
YouTube
button
video,
is released,
you
the connection is broken.
you saw the demo on the current measurement. All right, I just want you to know that there are also other type of. Let me close this one. There are also other type of meter features. It doesn't include the on your meter, but there's one type. It's called clamp clamp meter, right? So if you Google that clamp current meter, you will see the image similar to this, right? So they have a big clamp, so you will just like the wire goes through this, they can measure the current from the conductor or cable, right?
The opposite
so
of
as
an
you can see on
NOPD
here, right? So
is a
that
normally
you
closed
cannot
push button,
measure
or
two,
NCPD.
especially when you
It breaks a connection between
zoom
two
in a little bit,
contacts when the button is
especially when
pressed,
you have
and
the
makes one when
current
the
in
button
the
is
opposite
released.
direction. That won't get the accurate measurement, right? So you have to measure one at a time. So I just want you to know there's some feature for the clamp meter, right? But it's not available on your meter. It's more like an
The rotary
industry
switch shown below
application
makes a
with that,
connection
right? So
between one
as you can
primary
see,
contact
in the industry,
and any one of
it's
several
not
other contacts
very
by turning a knob.
convenient to
You
cut
can
the
remember
wire
how a rotary
in
switch
order
works
to
by
insert
remembering the
your
word rotate.
current meter
Rotating the knob
to
changes
measure
the
that, right?
connection
So
and closes the
it's
circuit.
not practical, right? Just in case if you're curious, so that's the solution, right? So now this is another page of will be some questions on your online quiz. All right, I suggest you to pause the video to work on those questions on the particular page for the DMM meter. Right, so I'll pause a little bit before I move on to the next section. Okay, so let's move on. So this is the section 3, right? Remember we have 4 sections for this virtual lab. This is section 3. I want to talk about electrical switches and current wiring. Alright, so in this part, I will just keep using the online tutorial to show you because they are very good materials. So there are 3 tutorials. We will look at them one at a time. Alright, so also there will be some quiz questions from the tutorial. So let's look at the first one. How do we test the on-off switch? Alright, so let me open that. So I will have the link available under the video, so you can get the link. You can watch by yourself. All right. So let's do it together. So that's the tutorial. So first, you can see here, right? Just in case if you don't quite understand this picture or diagram, right? So this is a symbol. They use that to represent a switch. Right, on-off switch, right? So again, you need to remove from the circuit and check with the ohm meter, right? Of course, we have DMM, right? That means we just need to set up DMM to the resistance measurement, right? Over here shows the ohms, right? So that's the meter, right? So if the switch is open, you can see here it has a gap, right? So that means you will read infinite reading. So that symbol normally in math represent infinite, right? So on the meter, you will see. Let me get my pencil. You will see some of the meter use the O dot L represent this kind of situation, this sort of infinite reading, right? I think they represent overload, right? So or over limit, right? It's up to you to understand. So that is some tell you that the reading is too big, right? So because the switch is open, right? So that's what you see out here, and again, over here, same switch. When it's become closed, right? You can see the reading from the infinite go to near zero, right? Almost zero. So this is what you see on the on-off switch, right? This you can see this is very similar to at home, right? So when you close the light switch, right? In your room, like a wall switch, right? So that's very similar to that, right? When you open, then the current being cut off, the light is off. When you close, right, the current will pass through, right? But actually, that switch turned to near zero reading on the resistance, right? So over here, there's something we need to talk about it, right? There's some confusing part, all right? So if we have the switch in the circuit, wire into the circuit, so you can see this is a circuit diagram. We have a 6-volt DC that is almost like a battery, so that goes through a switch, then connect to the light bulb, then go back to the battery. So this is a loop, right? So if the switch is closed, right? So you this is, oh, sorry, I forgot about this. Is a different way, all right? So this right now we are talking about voltmeter, right? The on-off switch, without moving it from the circuit, you need to use the voltmeter. So which is also very common in this course. We use the resistance or continuity, and also we use voltmeter. So in this situation, if you measure across the switch, you actually will read almost 0 volt. As you can see here, the comments here, many beginning students assume that it should be measured the supply voltage instead, but actually that's wrong, right? However, the closed switch is similar to a straight wire which has no voltage drop. It has a little bit, very little bit resistance. Almost you can ignore that. So that's why the reading across this switch is almost 0 volt. So all this supply 6 volt is applied, power supply is applied on the light bulb. So that's where you read the 6 volt across the light bulb. So that's why the light bulb turn on, right? It has consumed the power, or the 6 volt power is applying on the light bulb. You see the light bulb turn on with the switch closed. But remember, you should read 0 volt on the switch cross, right? And if you open the switch, right? So as you can see here with the animation, once the switch is open, you know the light bulb turn off, right? And of course, there's no voltage drop across the light bulb, right? Because that cut off the current, right? So that's why over here you read 0 volt across the light bulb. But if you measure the switch again, so now you should read the 6 volt across the switch, right? So that's what we usually see on the circuit, and also that's what we use for this course. Later on you will see the application in the lab. All right, so that's basically this tutorial. Let's quickly go through this. Open switch, test with ohmmeter reads open switch with the open switch with infinite, right? Infinite ohm, and then the closed switch is read ohm meter, that'll be 0, right? And if you read the voltage, right, voltage across the closed switch, remember that I talked about that, then that'll be the 0 volt, right? And the voltage across the open switch, right? Once that open, the supply power, the voltage will apply on the switch, right? So that's basically the first tutorial. And so again, you can pause the video now. You will see some of the questions related to the tutorial. You need to work on that if you want, all right? Or if you want to go straight forward, you can continue to watch the video, then work on those questions later, right? So this is just a first one. All right, so let's look at the last one. The last tutorial relate to how do we build a circuit? How do we assemble the circuit from a schematic diagram? This is some of the technique I need you to learn at least at the beginning. All right, as you go, you're building more skills. You're more getting better and better at this. You don't have to use this technique anymore. But at the beginning, I really wish everybody will start from here. All right, so let's look at that tutorial. as you can see here, right, electronics or electrical, similar thing, right? Find it difficult to properly construct a circuit by reading a schematic diagram. Because on the diagram you will find a lot of symbols, right, represent the different devices, right? We will have a similar symbols like this. You're gonna learn a lot of symbols for the circuits, all right? So as you can see here, you can see these this is like a loop, right? So you have a power supply and the load, a switch, right? So light bulb and the resistance, right? So that's, or you could see here, right? You basically this one says that you could have a very big circuit. This is what you see in a electronic circuit. Similar with our course electrical circuit, we're gonna have a complicated circuit as we go, right? So, and then when you start to build those circuits, you need to record where you at, right? You need to know exactly which part you already finished, which part you haven't, right? Which part that, for example, if you need to stop in the middle, and then after that you need to come back to carry on, where do you start, right? You don't want to lose your track. So how do we do that? Right, so that's just how do we keep track? So this is what a suggestion, right? So they're calling this a squiggly line method, right? So this technique we use some sort of record, right, a mark on the diagram, right? So once you make one connection, you make a mark on the diagram, right? So as you go, you start to record different part of the circuit, right? So in this way, you keep track, right? So this give you an example, right? So let's see here. There's a circuit. Click to connect the wire. All right. So let's see here. You can see right now it connect to here, right? Connect. This is power supply. The negative to a wire and connect to the negative part of the ammeter. So this is on the diagram, this is the ammeter. So basically that's this connection, right? So you'll see here that basically you draw a curved line, or the whatever you want, the mark. You can use a check mark, or you can use a whatever mark you prefer, right, to record on the diagram. So in this way, okay, you know this part is done. I need to continue, right? So for that, let's do it next. And then you can see here from the ammeter positive to the 10 the resistance, that be from this part, right? This part of section, as you can see, kilo ohm. Yeah, so that's over here, right? So you can see the next part. You can see as you go, right? As you go, and you want to connect this part. So that's basically the red part, right? So once you're done, you cross that, right? So as you can see here, once you think maybe, oh, okay, I finished the circuit, but actually no, right? If you look at your diagram, you will find, okay, I already cross out those connections. I still don't have those two connections didn't cross. So that means you haven't made those two connections. So that's why you can see here it says that those two you haven't connect yet, right? But if you look at the circuit, right? If it's a very complicated circuit, you will see lots of connections. It's not easy, not like the first spot you can see the missing connections, right? So, but on the diagram you can see here there's some records, right? So that's why follow this. You find out this one haven't connected, and then you connect it, then cross out, right? Then that's next part, right? So you'll see here. So that's the connection, and that's the line, right? So it's simple technique, but at the beginning, I really hope everybody start to recognize the importance of this, to apply this technique in the lab. Like I said, as you go, you become more proficient, and then you don't have to use that all the time, right? So this is just the the tutorial, third tutorial. Again, there's one page on the quiz. You need to work on that, right? So now let's look at the lab room. Right. So this part I will show you a walkthrough. I show the video in the room. The lab room is B1033, and then after that I will focus on the I use the real equipment in the lab. We'll talk about the overview and terminal wiring, and also switch and push buttons, right? Similar to the tutorial we just learned. All right, so that's let me show you the video. I have the video on here. Okay, so this is the first video, right? So you can see this is the room B1033, right? So that's the outside. I'm gonna start to play the video. Right, once you walk into the room, right, I try to give you a real feeling, right? Even though if you don't have the scheduled lab in the first week, you can have that. When you walk in the room, right, there's some equipment over here at the door, and there's some whiteboard, right? Then most of the room will be stations around the room, right? So as you can see here, right now I'm focusing on one station. There will be 20 stations in the room. So this is the part of the electrical. Actually, this course later on, at the very end, we will start to talk about the PLC. So this is the Siemens PLC. On here you have some display screen, and also electrical devices, right? Indicator lights, push button, and select switches. And also this part you will have also some of the pneumatic equipment, cylinders, right? So we'll learn that more in Controls 2. But in the end of this course, we will start to talk about this a little bit. Again, we have a 20 station. We also have computers, right? So social bits. There are also other equipment used for other course, right? So this is one equipment. Again, probably at the end of the course, we will start to use it. We have 3 of them. There's one right beside the door when we walk in. This is one of them, right? So this is what we call process control, right? So we use this sort of equipment to practice we use water as a fluid, right? So to look at the flow, pressure, level. But that's again the end. So now you're seeing that's the majority part of the room we'll use for this course. The trainers, right? We have 10 trainers, and this one is a special one. This is a teacher station. This one has a motor. You can see here, motor connected. And on the regular, we have, I believe, we have 10 of this. The regular station, we don't have a motor, but we can use the teacher station as a demo, right? So as you can see, this is on a plywood, right? So that's a big box. It has a drop-down power supply, and that's the switch. Over here, that's the plug-in, and that's the front panel, right? So you have some device. There's a handle. I'm trying to open it, right? Once we open, we look inside. That's all the devices on the back. Also, there's some motor starter you are seeing right now, and then mostly you can see those are the terminals. We will wire that circuit, use that part, right? So at the bottom there's different relays. We will use that later, right? So this is the station. So this station that'll be majority part of your lab, right? So this is the first walkthrough, right? And now we start to talk about the details, all right? So again, we have 10 trainers, or what we call stations. So let's first look at a picture, right? We have a big box. We call the main panel, right? So this is main panel, and also you can see here power switch with lockout, and that's the ABB power switch, right? And this tag is the logout, right? We use this. We don't have this anymore, right? Because it become a little bit redundant, not necessary, because we have the DC 24 volt on the trainer. So it's not really necessary to use logout and tagout, but over here just use that as the demonstration for some of the safety measurement. We will have some topic talk about this, right? But that's not what we will handle every day, right? That become a little bit too much. So that's why we remove that. And also on the station, you will see some of the sensors. As you can see here, photo sensors. We will talk about that. Right? Some of you may notice if you have a garage, at the bottom of your garage door, you have sensors, right? So that's similar to that. And also, there's a remote control box. If you follow that, that'll be something on the plywood, something not part of the main panel. Right? That's why this is called main. Right, and that's something somewhere else, right? Also connect to the main panel, but not as part of that, right? So if you open the door, this is a more clear view, right, than the video. So if you look at on the front panel, right, so you have all the indicators, right, different colors, right? Those are the timers, push button, switches, e-stop, right? You will learn that later on. So that's on the back. Right, so on the back of the door, you will see those are the contacts where the wire connect to. So those wires, cables, they all connect into here, right? So the majority part of the panel inside is this terminal, right? Those are the connections. We will use the wire to connect them, right? So again, each trainer has two motor starter, non-reversing. Those are the two. Again, there's no point for me to talk about that, but we'll learn that later. Right? There's also another one, forward reversing. Again, we'll talk about that. Right? So this is more detailed. Remember, I talked about those sensors, right? So you can see there are so many of them, right? We'll also learn that. You can see here, there's a sensor, there's a reflector, right? And that's the remote control box. You can see here that box has a conduit or the pipe connect into the main, right? So that's on the side, and then that's the power supply is being controlled by the switch. We also have a 3-wire control box. Later on you will use that, right? With the logout, tagout, like I said, I only use a little bit time on here. We'll have a separate the topic talk about that, right? So that's basically where you turn off the power, turn on and turn off. So then in the industry, if you want to safely turn off the power, for example, you work on the main panel, right? But the power switch is not close by, it's somewhere else. You first need to power off. After you power off, you need to put your lock on that. With lock, nobody can turn the power back on because you need to work on the panel. You don't want to do that. You're working on the panel, but somebody come along to turn on the power, right? So that's the reason for logout and tagout, right? So on the lock, there are some of the like a generic logout, the tag. And then you can see here those are the two tags I use when I work as an electrician. You can see that has my name, right? Then also the warning message, right? So something like that, right? So you can have that tied up with your lock. Then somebody know, okay, this is somebody, Michael Zhang is working on the equipment, right? So if I need power on, I need to contact with Michael. Right, so that's the purpose of its lockout. Right, you can see here on the corner here in the industry there will be some control device that we call panel view. So by the way, you will learn this. How do you program this image? Right, the touch screen later on in the automation 3. Right, so. So this kind of tag has a sticker on there, right? So like a sticky pad or something like that. You can use this tag to cover all the screen, right? Not only you can log out on the power supply, then you can also get people on the panel, right? So on the HMI, so people will know, okay, I cannot operate on this because that also can potentially cause some damage if somebody working on the equipment. Over here, there are also other pictures, right? That's in the industry, right? So this is, you can see this is the lock for a fence, right? So once you lock it, nobody can lock the fence, right? If you go into a big machine, you don't want people lock the gate for you. So you locked inside. You don't want to have that happen, right? And then over here you can see this is the lockout for the some sort of a valve, right? You don't want people to adjust that anymore, so you can totally lock it out, right? And then you can see here this is the padlock, right? So when you have maybe 3 people work on the same machine, right? You need to have 3 locks on that. So with this, you can use one padlock, then the different holes, right? So each single one of the worker on the equipment should have the lock on it by itself. So we all finish, we all unlock, then we can start. If there's one single lock on the padlock, there's no way we can turn on the machine. In this way, we make sure everybody is safe, right? Okay, so let's talk about the terminals, right? So on the left-hand side, you will see here is a pretty common screw terminal. You must seen something like this before, right? It's pretty common, right? So this is where you can make the wire connection, and this is only a simple one, right? Notice that for each terminal, you can also have more than one wires on there, so make connections. So this is the old style. Right. So what we're using in this course is a new style. It's what we call a push-in terminal, right? So that's the picture you can see here. The term is not official, right? You will hear lots of people talk about locked in or spring loaded, right? So lots of different terms. So the reason it's different is that with this type of terminal, you need to use screwdriver, right? So you need to unscrew it and tie it up. But for this type of terminal, we don't need a screwdriver to turn the screw. But we do have a screwdriver, but for different purposes. So on this type of terminal, as you can see here, that's the one we use in the panel. So each vertical, right? So you can see here, that's number 1, and then that's number 2. So each terminal has 4 connections. So you can see here it's being occupied on the top, right? So that's where you connect to it. So you can see here PB1. So that's where the wire connect to PB1 already on the panel, right? So if you want to know, right? So PB1 you can see here, right? So this is PB1, the blue button on the panel, right? So that is actually is this one, right? So that wire go into this and connect to the panel. Where does it connect to? Right? Connect to here. So that's the wire. And then also it has 1, 2, 3. There are also 3 the round holes on there for you to wire on. So you can wire multiple wires. For this, there has 2 wires connect to one terminal, right? They make connection. So in this one, if you insert a wire into this hole, that will have connection to this wire, right? You can also have 2 more. So for each terminal, it has 4 different connections, right? So it also have different numbers on that. We'll talk about more in the following lecture, right? So this is PB1, 4 wires connect to there. And PB2, so if you're curious, let's go back again, right? So if you look at here, right? So this is the back of the PB1. You see here, 1, 2, 3, 4, right? So that's those 4 wires actually connect to here, right? So inside the panel. So what exactly is inside this type of terminal, right? This is what I got from Omron. So if you look at the diagram, right? So this is the wire going in, so we can push in, right? So this is the clamp spring, press the wire to lock it into place, right? So this is the spring, right? Clamp spring. So this is the wire you go in, right? So what kind of wire you can go in? You can use this, right? You can see here the wire with furrows. the furrow is the connector. You can see here the yellow wire with some of the sort of connections. You just insert on there, and then that become a pretty nice connector like this one, right? Or you can use solid wire. You can see here if you have a copper wire, right, it itself can be used to insert in there, right? Or you can have some stranded wire, but that's not very common like this, multiple wires in there. So when you insert from one hole on here, that push in and the spring lock into place, and at the bottom you can see here conductive metal. So that's sort of feeding connect to other place, right? So that's why all these vertical full holes are connected together when you push the wire inside. And also on the side you can see here there's another hole on here, right? So if you imagine if you have a screwdriver to insert, to plug in from this hole, that's gonna push this spring downward, so that's gonna release the clamp, right? So once you push that spring away, so your wire is free, you can take it out. So that's why this is called push-in terminal, right? And on here, so I just got to give you some of the points on the terminals, right? Each terminal has 4. You already know that, right? So each point is a pair of holes. Round hole to insert wire. Okay, that's what I mean, right? So you can see here you have a round holes. You have a square holes, right? So in a pair, right? So that's something you need to be aware, right? So the round hole for the wire, the square hole for the screwdriver, right? So that we already talked about that. So you can see here, if it's difficult to push in, you have to normally, right? Normally you can just in the you know what? I'm gonna show you a video, right? So that's just look at this. Second video. Let's look at the second video here. Okay, so that's the video I show you. All right, so let's move maybe from here, right? So you can see here, that's the furrow, right? The connector, the wire in there. And then I show you the screwdriver. That's on the trainer, right? So you can see here, if you push the wire going to the wrong hole, you can just push in. Then you can see here it's locked in here, right? You can do a gentle pull. You can test if in place. If you need to connect to somewhere else, same thing, right? As long as you can go into the wrong hole, you can go to anywhere, right? You can see here, as long as the connection out here, right? So this is how do you make the connection. How do you remove it? When you remove it, you need to use the screwdriver to push in on the square hole, right? The square hole on this, you can see here, this one is for this one, and this square hole is for this one, right? So if you need to remove this wire, you need to insert this screwdriver into this square hole, right? So that's what I'm doing right now. Push in, then you know that happened, right? When you push in, you release the spring, so the wire can be removed, right? You cannot directly pull the wire out. You have to release that, right? So this is how do you do that with the connection. So now I'm showing you, if you're really hard to get into, right? So example is become very weak, you can use your screwdriver to help you. Then you can insert in there, right? Just in case some of the wire has been used for a very long time, if the furrow is not very strong enough, you can do that, right? So now I'm showing you the with the DMM, right? So the probe from the meter, you can consider that as a solid wire, or same thing as the furrow, right? So you can also plug it into those round holes. And the good thing about this, once you plug in, right, of course you don't have to push in, right? You can just do a light tap, right? You can measure it and go. But if you want hand free, you can insert your probe into the round hole, then leave that in there. So you can use your hand to operate on your buttons. If you need to do that, right? So you can see here, I can leave it in there, so I can do something else with my hand, right? If I need to continuously measure that voltage or resistance or something like that, right? But remember, when you remove it, you need to do the same thing. Use your screwdriver to release it, right? Same thing on here on the terminal, right? Okay, so this is the connect. That's basically what if I said. I already demonstrated that for you. All right. So there are also other things on the terminal. You can see here. Those are the jumpers. Right now I'm showing you the power supply. All the red is positive 24. All the black is the negative. Right? It's a 0 volt. Some people have a confusion about that. That's actually 0 volt, but it shows negative. All right, and it's just a common labeling for the industry. So notice on here, you can see once you have this power supply going to this hole, all these holes are connected because they are jumpers, right? So that's where you can get all the power supply from all the holes here. With the 0 volt, same thing. There's only one 0 volt going to one hole. All the rest of this whole block, right, which short by the jumpers, you can connect to the 0 volt, right? Because you're gonna need a lot of power supply, right? And also you can see on the 630, this terminal has 4 holes available for you, so they can be used as a spare. Right. Later on, your circuit, if you need to create a spare connection, you can use this. Right. Okay, so let's talk about the switch and the push buttons. All right. So as you can see, this is what we call the toggle switch, or call flip, or locked, or latched, or different names. All right. Similar to the one we use at home to turn on and off the light. But commonly in the industry, we use that term called maintain, right? So also left position, you can see here left position is we call that normal position, right? So that's what happened in the switch. You can see when you flip to the left, internal connect, this is a pole, right? And then you have 3 connections, terminal connections. So that means this middle one is connected to here. So that's why it's called normally closed contact, B and C. But A is being cut off, right? But if you flip that to the right hand side, and the internal pole change, and then B and A is connected, and C is being cut off, right? So that's what it shows here. All right, on the lecture we'll talk about more, right? But over here, I'll just let you know the term maintained. The other term is called momentary. In contrast, momentary, that means you have a spring. Right. So, for example, this is a push button. So this spring will push this contact to separate these connections. Right. So the position the spring push to is called normal position. Right. So that's why the top is called normally open, because if you don't press the button, the contact is open. But the other configuration, if you see here, right, we could have a different construction on here. So this spring will push the contact close. So those are the 2 different configuration, 2 different type of buttons. Normally open is it's broken, right? When you press the button, it becomes closed. But normally closed, if you leave it alone, it's closed. But if you press down, you make it open, right? So in the industry, right? So you can see this is the pictures. This is what you see here. We will just combine the contacts together. So I feel that I go into too much details. I will maybe skip some of them, and then we'll talk about more details on the lecture. So basically, in the industry, right, so we can combine both as one device on one. You can see here, right? So we can have one button control 2 different type of the contact. You can see here we have 2 of them, right? So 1 and 2 is normally closed. 3 and 4 is normally open. And same thing for the switches, right? So obviously you can see those are very complicated switches, right? Again, on the lecture and the following lab, I will talk about it, right? So let's go next. All right. So on this slide, I'm showing you the diagram, right? So normally you see a loop. So that's what you normally see people draw the diagram like that. But in this course, when we look at the controls diagram, we're using what we call ladder diagram. So this is a different way to draw that. So no, we don't draw the diagram like this way, all right? So this is not the way you will use for this course, but this is the way. Instead of that, all right? So the power supply will be drawn on the side, positive and negative here, right? So in between this positive and negative, you start to draw the symbols to represent push buttons, pilot lights. Then you use connection, connect them, right? So this is what we call ladder diagram, because right now there's only one rung, right? R-U-N-G, one rung, just like the real ladder. If you have more rungs, right, more steps, you'll be more like that, right? So this is what we call the diagram, right? So we're going to start to use this type of diagram, all right? So what we will do with this one, we will use the S3. Sorry for my writing. I'm trying to maybe use a different one to label it. So that's the label for the device. Then we need to use number 1 and number 2. So you can see here to represent. This is what I mean by label. Oh, and number 4 doesn't work. To represent normally open contact. And then we use the PL3 and PL. Okay, it didn't work for me. Okay, sorry about the writing here. And this is X1. This is X2. So we will definitely learn details later, but right now I just need to do the demo. So those are the contact or terminal labels, okay, on the block. So then when we start to wire that circuit, we use the lines to just give me a minute if I can that, right? So let me just do the demo on here. Okay, look at the next one. Alright, so how do we wire the circuit? I don't know what's going on. So now over here, I use the SS3. You can see SS3 number 1, right? I insert in there, and then insert into the red block, right? So if I switch to here, so that means from this part, that's this part of connection, right? So I need to use squeezy line to record it. So that's what I connect in here, right? Okay. So all right, that's the connection from the power to the number 1 terminal on the SS3. Okay. Then I take a blue wire for control. So we need to label it. The other side of SS3 to connect to the PL3. Use my mouse. So that's here, PL3 right? And X1. So that's the connection on there, the blue wire, right? So let me show you the connection again. That's the other side, right? This is number 1. This is number 2. From here, I connect to the pilot line, right? So this is this blue connection on here. And then after that, I need to finish with a black wire. The black wire go to the other side of the PL, and then remember that goes to the black, right? Connect to the terminal here. So now I finish the first rung, right? So if you go back to there, I start from here to here, right? Finish the 1 rung. So I need to finish the next rung. So that's what you will see next. Same thing again from the power supply, 24 volt, any one of that, right? They all connected. Go into SS3. I need to find SS3. If you see here, that's SS3. Go to number 3. That's the first connection. Then again, blue wire connect to the number 4 and connect to the another pilot light, PL4, right? PL4 blue wire. Then I get another black wire, connect to the other end of PL4, then goes to the ground, right? So you can see here PL3, PL4, right? It's S1, S2, and then that connect to the 0 volt, which is black, right? So now I finished. I connected. So now I can lock the door, and then I can turn on the power, right? Once I turn on the power, you can see PL3 turn on and PL4 off, because the SS3 is on the left hand side, right? If I flip to the right hand side, then that switch, right? This one turn off, that one turn on, right? So I believe I demonstrate later on, right? PL4 on, right now it's on the right, so you can see here. That's the circuit connection. All right. So this is how do we build the circuit, right? We use those 3 things, right? Remember I demonstrated on that. Okay. So last one. I know it's a little bit long for this video. This is the last part we will finish. So one part of the troubleshooting and wire circuit technique is to measure the voltage, right? So over here you will see, remember that's part of the tutorial I went through with you, right? So that's something with the live circuit we can measure it, right? So for example, all right, so that's again, let me play another video, then we can work on the slide later, right? Right. So right now it's continuity. I need to switch to voltage, right? 200 volt, because the power supply is 24 volt, right? So need to be bigger than that. So right now I'm using this. You can see the black going to the 0 volt, right? So I can stay there hand free. If you work alone, you can even work that by yourself, right? So now the SS3 is on the left hand side, right? And then you can see I use the white probe to measure the SS3 number 1, terminal number 1. You can see here I haven't turned on the power, right? So that's the mistake I have, right? So you can see I turn on the power. All right. Alright, so turn on the power. You can see I measure that 24 volt power supply, and then I measure number 1, 24 volt that go into the switch. Then after the switch, you see 24 volt, right? Because 1, 2 is normally closed, and that go into the PL, right? PL get the 24 volt, then the light turn on, right? So that's what I'm showing on here, right? So you can see, that I'm trying to show you. You have the 24 volt, you see the pilot light on, right? But if you measure the next one, number 3, that's 24 volt power, and then number 3 you have 24 volt, right? It has power. Then on the other side, number 4 you don't have, because it's normally open, right? 24 and 0, right? You don't have voltage on the other side. Then you will see the PL4 off, because it doesn't have the 24 off. All right. Then I can flip the switch. Right? Once I flip switch, you can see PL3 turn off, PL4 turn on, right? And then that's because the voltage change. You can see 24 volts still there, and then number 1 it has 24, but because open, the other side doesn't have 24 anymore. And then over here you have 24, it's closed, 24 volt, and then you have a PL4 24 volt. So that's why PL4 is on. Alright, so that's that's something on there, but on here I just use this as an illustration. Alright, so over here you can see flip on the left hand side, right? This is 1, this is 2, it's closed, 3 and 4 is open. So that's why this is 24 on here, this is 0 volt on here. So you will read 24 on here, and 24 across over here you have 24, and then that supplied 24 volt to the pilot light. You see PL3 on, and over here that because connect to the power supply you will read 24 on here, but because that's open you will read 0 volt on here, and then the pilot light doesn't have power supply, that's 0 volt, right? So this is again flip to the left hand side, right? But when you flip that to the right hand side here, you can see you make the top contact open, right? Again, that's 1 and 2 and 3 and 4, but they change now, right? You still have 24 volt on here, but you don't have 24 volt on this, right? You have 0 volt, you have 0 volt on here, and PL3 is off. And in the same time, you have 24 on the terminal number 3, but because you flip to the right hand side, that make this contact close, so this will read 24 volt, and that will supply 24 volt to PL4. Then you see the PL4 turn on. Okay, alright, so this is the end of this virtual lab.